Hello and welcome back to the advanced course on R programming. So far we've done quite a lot in our data preparation. I thought it would be nice to mark it off here in our spreadsheet. So I'm not going to worry about the rows that come underneath, that come below, but basically we'll just mark off these red boxes and that will tell us which columns we've dealt with. So we've dealt with the industry column. As you recall, we removed these rows. Then we've dealt with the inception column. We decided to just keep it as is because it's not going to impact our analysis. Then we've also dealt with the state column because we were able to predict or derive with 100% certainty what the state is based on the city. So now we just have a few more left, and today we're going to talk about the employees column. We're going to learn how to use the median imputation method to proxy a value into this column. And we're going to talk about the growth column, and basically the same thing is going to happen. We're going to learn how to use the median imputation method to proxy a value into the growth column. Now I'll explain a little bit more detail what we're doing so that we have a plan of attack for today. So what you can see here is that we've got 500 companies, and if I highlight this row, then you can see that the average number of employees is 148 in across all these companies. And what we could do is we could just take that number, 148 employees, and just plug it into this cell over here. And that is a very coarse median imputation example, or that's an example of a coarse mean imputation, right? So that's not even us taking the median, we're taking the mean, so the average for this column, and we're just putting in here. So a bit of a step up from that is to take the, rather than for all of these companies, is just to take the companies that are in the retail sector. So let's have a look at that. Let's say I want to create a filter, and then I just want to look at the companies that are indeed only in the retail sector, because this company is in the retail sector. And then if I just go to my column here, now if I highlight all of this, then you'll see that the average is 209. So obviously there are stores where lots of employees are required in the retail sector. So the average has gone up. And now if we put in this number here, 209, that will be a much closer approximation to the reality, because this company does operate in the retail sector. Why would we proxy it with an average across all of the different sectors, including construction, including financial services, IT services? They're not very similar. The companies that are most similar to this company, GreenFacts, are the companies that also operate in the retail sector. So that is an even closer approximation. You could even take it a notch up. You could say, all right, we're going to look at only companies that are in the same state, in the state which has abbreviation SC. So you could do that. Or you could even look at the same city or other things that might impact your analysis. And this comes down to your industry knowledge, so your knowledge of your data set. Does it add value to filter your data set by the same state? Is there more similarities that way, or by year of inception, or maybe by the revenue figures? What will give you the biggest similarity in terms of employees? In our case, we're going to limit ourselves by filtering to the same industry, because that is a kind of a very sure or very certain approach. So it's not 100% certain, but it definitely, like, it even feels like that looking at companies in the similar industries is a bit of a more fair approach than just looking at companies across all industries. If you would like, you're welcome to take it a notch up and look at companies in the same state or city, or use other variables as well. Now that's in regards to similarities. And the other thing is that here in Excel we were talking about the mean, but in reality we're going to be looking at the median, because the median is less affected by outliers. And if you have a massive outlier here in the employees column, so maybe let's just sort it by descending here. So you'll see that we have a company that has 7,000 employees, and it is indeed in the retail sector. As you can imagine, that will skew the average a lot, so it will increase the average. Whereas if you take the median, it won't really impact the median that much, because it's only one, two values, or in total there's only 9 values out of 500 that are over 1,000. So as you can imagine, they will impact the average a lot, but not the median as much. So that's why we're going to be working with the median values. All right, so there it is. That's our plan of attack for the employees column. The growth column, exactly the same thing. We're going to be performing exactly the same procedures. So let's jump straight into it and get started on this analysis. And actually, I wanted to warn you, these next couple of tutorials where we're going to be using the median imputation method, they're going to be pretty intense, so prepare yourself for that. We're going to do quite a bit of coding. All right, let's get started. So first thing, we want to actually find this median, right? So first thing, of course, if I run this, we'll see that these are empty values and we're dealing with employees. So we have two columns here, one in retail, or two rows, one in retail, one in financial services. And so first of all, we're going to find what value we need to put in here, right? We're going to find out the median value, so median, for our data frame, which is fin, in the retail sector. So we want to add a filter, right? So I'm going to put the comma in right away. And here we want, well, right away, we'll just put in the column that we're dealing with, employees, right? So this is just all of the whole column for employees. Run that, there it is. If I run this, that is the median. That's because we've got NAs, and NAs mess up your median. So what we definitely need to do here is NA.RM equals true. So remove NAs. If we run that, we can see that the median is 56, and much less than the average. We can just check the mean for the same data, and just to make sure it's the same as what we saw in Excel. As you remember, it was 149, so it's exactly the same as what we saw in Excel, which is good. Now we're going to get rid of that, and with our median, what we want to do is we want to take it to that next level. We want to look at what is in the retail industry. So we're going to add a filter here. It's going to be fin $industry equals double equals. Don't forget it's double equals retail in quotation marks. All right, so that is our median for that industry. So once again, we've got this filter which subsets our data frame to only the retail industry rows. And then we're looking at the employees column, and then we're taking the median of that column and we're ignoring any NAs. So if we run that, we get 28. So as you can see, the median for the whole data set was 56. The median for the retail sector is actually 28. So it is actually the opposite. Very interesting. So that we saw that the average increased when we looked at just the retail sector. So if I replace that with the mean, right, for the average, you can see that the average increased from 149 to 209, but the median decreased. Very interesting observation, and might be a bit counterintuitive as opposed to what we discussed before. But nevertheless, that's the result we want. We want that proxy number. We want this number 28. So what we could do right now, we could put it into that row that we wanted to put it into right away. Like right now, we could put it in there. But a word of caution, it's always a good idea to save these statistics into separate variables or vectors, because before you override the data, because once you override the cells, you've now affected the median. If you want to recalculate the median, then you will already be including that new value that you're putting in there. So it's always a good idea to save these values, and we're going to do exactly that. We're going to put this value into median employee retail. So we remember what column it's for and what filter we applied. It's the retail sector. Run that, and now we've got our median employee retail here, 28. Beautiful. So now what we want to do is we want to replace that row. We want to replace that row with that value. We can, once again, we can address the row by itself using the ID or the row name. But what we're going to do is we're just going to create a filter, just assuming that there could have been multiple rows that we want to deal with. And, that's good practice for the future. So let's go ahead and do that. We're going to say fin, and then we want to say is.na fin $employees, right? So we're looking at the column for employees. We're finding everything that is a missing value in there, and then we're subsetting by that. Then we want to say comma nothing, of course, but we want to add additional filter, because if we just run that, we'll get the retail and the services industry. So we want an additional condition here. We want to say and fin $, where is my $? Here it is. Industry double equals retail quotation marks, right? So if I run that, then we have that same one line that we do need to replace for green facts. And now we know we're just going to work with the employees column. We're going to replace that with median employee retail. So if I run that, now we just want to check, and we want to pick out that one row that we are we were working with, which is row number 3. So let's just run that. As you can see, employees is 28. So we have successfully applied the median imputation method. Congratulations. It's a big step in data preparation, of course. All right, and now we need to do the same exact thing for this other company, which we have here in the financial services sector, which has no employees. So I encourage you to pause this video and practice that. So do the same thing, check for the mean, median, where was it? So just basically check for the mean, median, and everything, and how they change if you include the industry, not include the industry, and then just perform this. And now I'm going to do the same thing here. So now I'm going to basically copy this, and let's have a look at the mean, for instance. Let's see how the mean changes for financial services. So the mean is 211. Well, that's for the financial services. So basically what I wanted actually to do is get rid of this filter. So don't filter the industry, and just for everything, it's 148, then it becomes 211. So it goes up. And now if I look at the median for the same two, what is the median? It was 56, and then it goes to 80. So the median also goes up in this case. Very interesting. Okay, so now what we want to do is we want to just perform the same calculations or same assignments, and we want to create a variable. Here we'll say finserv, financial services, run that, and now we have this, which should contain our 80 value, which is good. And now we just want to assign it. So same as here, we're creating this filter, financial services, right? So there it is. We're checking that it is an NA, a missing value, and the industry is financial services. And now we just working with the same row, but we're assigning the employees column a value which we've saved over here. There we go. So if we run that, and now we have a look at it, check. So financial data set row with the name 330, comma nothing. So Westminster financial services, and we've successfully applied a median imputation method. Again, congratulations. So if I now run this, you will see that we only have 4 more rows to deal with. We're getting very close to completing our data preparation phase. It's getting very exciting. And I hope the median imputation method made sense. It is a very powerful method for lots of different types of analyses. And yeah, I encourage you to practice it whenever you have a chance to, just so that you get the hang of it, and then you see all these ways you can increase your similarity of what you're producing to other records in your data set. And on that note, I look forward to seeing you on the next tutorial. Until then, happy coding!